A program is essentially a sequence of machine instructions stored in a memory. Now, each machine instruction performs a specific operation and is written in the computer's native language. Now, understanding this execution flow is essential to grasp how the system works from both the software and hardware perspectives. Now, to follow along with this course, you don't need any special hardware, just a computer with a keyboard and a mouse is enough. And all the exercises in this course can be done on most modern computers running Linux or using a Linux-like environment, or it can be Windows. So it doesn't matter at all, to be honest. Now, we typically write programs using high-level programming languages like Python, Java, or C, C++. Yeah, these are the programming languages, right, that a human can read. You can't read this binary code, right? Nor this, right? Yeah. And among this, the Python remains one of the most popular choices and essentially common on platforms like Raspberry Pi. And to create and execute simple Hello World program in Python, we will create a new file and we will name it main.py. Let's, for example, main.py. Oops. We got the two, and here what we will do is basically we will print hello world auxiliary, and that's it. Or you can also do that with the text editor as well. It doesn't matter at all. Or let's use the mouse pad, or yeah, we don't have the mouse pad, so we will use the text editor. Note something. Yeah, I don't know the name of this text editor, so we could launch one from the terminal, but in this case we will just run it from here. Yes, open new, go to text editor. Now it's a GNOME text editor, right? GNOME text editor, main.py, and that's it. Here it will open the main.py. We will write print hello world, and yeah, you can see we have the syntax highlighting here, coloring, discard this here, and ls you can see we have the main.py, and basically we will run it from the main.py and Python 3 main.py, and you can see hello world here, and we can do the exactly same thing on the Visual Studio as well. Terminal, new terminal, main Python 3 main.py, and you can see hello world auxiliary. Also, we will increase the text size a bit, so you can see font size is gonna be 29, 22. Text editor font size 26, maybe. Yeah, that's okay. 24 is better. And here we can use plus and minus to increase the user interface. With Control plus and Control minus, we can increase the and decrease the user interface size in Visual Studio. But this will basically serve the same purpose. It's just more nicer, basically. And yeah, we have run the program, and you can see we got the printed hello world and hello world auxiliary with two separate Python files. And we can do the same on the C as well, main.c, or let's say test.c. And first we will need to include the std standard input output, stdio.h, and integer main. It's gonna be return void printf hello world from C, and new line return 0, so our application will close after execution. Yeah, Basically, that's it. And as I said, we can do the same. You can see I have test.c here. Now we have saved the file in test.c. Now we will need to compile it. So as you see, it's pretty different with the Python, and you will see and you will understand why it is, right? Because you need to compile it, compile the C code to run it. So hello world, and here we will test.c. And here you will see that we have the hello world here, created new program, and we will just run it with the hello world. And here we are, we have printed the hello from C text. Now, this practical comparison highlights the difference between the interpreted language, which is Python, and compiled language, which is C or C++ or many other languages. So there's so much compiled languages. And yeah, Python translates and runs the code line by line, but the C code, on the other hand, must be compiled first into machine instructions before it can be executed. Now, C allows us to better observe how instructions interact with the underlying hardware, which is why it is preferred language for this course. So for the rest of this course, we will mainly use C, but we can go through Java, Python, according to examples to learn best. And whether a program comes from an interpreter or a compiled file, its instructions and data must be loaded into the memory before the CPU can run them. Here's what happens during the execution. The CPU, or let's actually, if you remember from the previous lecture of our course, and I'm sure you remember it, we had some diagram written, drawn by me, and we will open that and I will show you something here. Let's move it into Ubuntu, and here our diagram. Yes, where is our diagram? Yeah, it isn't here. Yeah, here we have figure 1.1.jpg file. Now, what you're seeing here is basically the CPU fetches instructions from memory by placing the address on the address bus and signaling the read operation on the control bus. You can see the memory system responds by placing the instruction on the data bus for the CPU to receive, right here, data bus. And if data needs to be written back to the memory, the CPU uses data bus to send it. The address bus here indicate where to store it, and the control bus to signal a write operation. Now, this process repeats continuously while the program runs. Now, programs also communicate with the input-output devices, such as human interface devices or HID. HID, yeah, which is keyboard, mouse, or touch screen, and the machine interface devices, which is basically like storage devices, network cards, and so on and so forth. So input-output devices are much slower than the CPU and memory due to varying speeds and data timing. Now, they require explicitly programming instructions to operate correctly, which is where drivers come into play. Although the advanced input-output programming for now is beyond this course, we will still use a terminal screen for the output. Now, the operating systems provides built-in input-output functions, and the C runtime library here includes functions to access them easily with this std input output header file. And to support the programming tasks in this course, you will need a working Linux-based environment. This could be a native Linux machine, a virtual machine, or a Windows Subsystem Linux, WSL. It's a relatively new thing, I can say. Or you can also use the Windows computer, but it is better to use the Windows Linux as well, specifically Debian-based operating system. Now you can see these are the Debian-based operating system, or you can use the Debian itself. The best operating system for a beginner, if I can say, it is Linux Mint. I would recommend the Linux Mint if you are a beginner, because of the user interface that is pretty similar to Windows 1 as well. And we have the Linux documentation tools as well, like Linux tools provide extensive documentations. It's the Linux help is not as useless as Windows help. So yeah, GCC help GCC help will give you basic information about the options and parameters you can use with the GCC command. You can use man. So this is basically manual pager utility. You can find there's almost man page for every command in Linux. For example, we can do ls man or man ls, and you can see we have the ls page for man. That will be pretty handy when you develop or don't know the commands for sure. And you need to install the info for the deep dives. Sudo apt install info. Now it's already installed and newest version. Info. Now you can see info. I can say that better alternative for man, but man is useful as well. You can choose how much information you need to read. So if the info provides more information than man. And yeah, basically after doing the steps, you also need a word processor. Now, by the word processor, I mean not to use the LibreOffice or Microsoft Word. They insert hidden formatting into your codes, which can break your code. But you need to just, at the lowest level, you can use the Vim. So the apt install Vim. This is for more advanced users, but once you start using Vim, you will get addicted to it. This is a keyboard based. Vim is keyboard based, you can see. Now, if you don't know using the Vim, like you can probably use my keyboard has some kind of problem here, or I don't know. Yeah. And basically, what I recommend you to use here, it is either Vim, if you want more advanced or professional look vibes, or you can use Visual Studio Code, which I recommend for flexibility and graphical user interface features. Now, you can also download the themes for you, like let's say, if you want, we can also, yeah, here, it is easily customizable, and there's an extension, so you can almost develop for any languages here, even ARM, which we will develop in next lectures. Yeah, the Visual Studio Code is good, but if you like open source, what I can recommend, as you know, Visual Studio Code is not open source fully, so I think it was VS Codium. Yeah, open source binaries for VS Code. Now this is basically the same, just an open source. And in my Windows machine, I use the Visual Studio Codium. But yeah, it's also usable. And how can you use the Visual Studio Code, install the Visual Studio Code is from the apt, is sudo apt install code snap. Oh yeah, sudo snap install code. And code is already installed. And you can also download from the binary files and compile it yourself, or just download the dev file into your computer. Click on release or install. Yeah, here we are. You can download for Windows, macOS, Linux. You can see if you are using the Linux machine, you need to install the dev file. Basically, it's almost 100 megabytes. And yeah, and in order to create some document or open some document, you just need to add code before your file. If you want to create a new file, my new file dot, for example, txt, you can even edit the txt files. And here we are. Now you can select the languages, C, and yeah, include studio.h and so on and so forth. And yeah, our lecture is been almost 18 minutes. That's it with our lecture. Thank you for watching. In this lecture, what we have basically you learned is CPU executes instructions and contains fast internal memory. Memory stores data and instructions. Input-output enables external communication and storage. Bus, basically bus transfers the data, addresses, and control signals. Program execution is basically how instructions move through the system. And programming environment, which is customizable, and how to prepare your Linux environment for development. And yeah, that's it with our lecture. In our next lecture, we will begin learning how data is stored in a memory, get introduced to the C language, and learn how to use debugger as an educational tool. I'm Tayfun. That's it with our lecture. Thank you for watching, and I'm waiting you in the next lecture.